You're welcome back from break. We want to do a kind of roundup on indices by looking into general examples covering different concepts on indices as I have taught you every concept before now. So, let's consider this example 1 as we enter into the roundup section on indices. Simplify 2 raised to the power x plus 3 divided by 2 raised to the power x plus 1. Here, we have common bases. Pick one of the common bases. 2 here as a base number, here as a base number. So pick one. Now change the division sign to subtraction and let that subtraction operate the 2 powers over this chosen base. That is x plus 3 minus bracket x plus 1. That is what we mean. So it will be 2 raised to the power x plus 3. I open this bracket with 1. There is an invisible 1 here at the back of this bracket. I open the bracket with it. 1 times x is x. 1 times plus 3 is plus 3. Now, what am I opening this bracket with? Negative 1. There is an invisible 1 here with the visible negative, meaning that we have negative 1 at the back of this, in front of this bracket. So that negative 1 times x is negative x. Negative 1 times positive 1, that's negative 1. So we have 2 raised to the power 3 minus 1 plus x minus x. I group the figures beside figure, letters beside letter. So we have 2 raised to the power 3 minus 1 is 2. Plus x minus x is 0. So, meaning that we have only 2 left in the power region. 2 raised to the power 2 is 4, and that is the answer. Example 2. Simplify m raised to the power negative 1 divided by m raised to the power negative 3. There are 2 approaches available here. Number 1, m raised to the power minus 1 minus 3. What do I mean? Pick one of the common bases. I pick it, m. Now, change the division to subtraction and let it operate the 2 powers, negative 1 and negative 3. So, that subtraction that we generate from this division is this one, is this. The negative 1 already in existence is this. The negative 3 already in existence is this. I bracket it because there is another sign that is like it coming in between. That's why I bracket this. So, in mathematics, when 2 signs follow each other without any figure or letter in between, you multiply those 2 signs together. So, these 2 signs, negative and negative here, these 2 negative signs, they follow each other closely without any figure or letter separating them. Therefore, you multiply those 2 signs. And this negative times negative, which gives positive. So it will be negative 1, positive 3. Do you understand? Now, when you have negative 1, positive 3, it's the same thing as m raised to the power positive 3, negative 1. It's the same thing. And easily you can remember 3 minus 1 is 2. So answer is m raised to the power 2. The second approach to this same question is when you rewrite m raised to the power minus 1 divided by m raised to the power minus 3 has 1 over m. M raised to the power negative 1 is rewritten as 1 over m divided by m raised to the power negative 3 is rewritten as 1 over m raised to the power 3. I think this is not strange to you. So you can now apply the normal principle in division as 1 over m times m raised to the power 3 over 1. Do you understand? Normal principle that changes division to its inverse. The inverse of division is multiplication. And as such, the divisor 1 over m raised to the power 3 also will change to its own inverse, which is m raised to the power 3 divided by 1. So, 1 times m raised to the power 3, that is m raised to the power 3, over m times 1, that is m raised to the power 1. M is having power 1. Yes, you can now round it up by having m raised to power 3 minus 1. Finally, m raised to power 2. Or from here, you can have m times m times m. That is m raised to power 3 all over just m. And 1 m will take care of 1 m. So you have m times m left. M times m means m squared. It's the same thing. Let's consider example 3. Simplify 2 raised to power 3 divided by 2 raised to power negative 1 times 4. You can see we have two operations together. So this is 2 raised to power 3 divided by 2 raised to power negative 1 times 2 raised to power 2. Try to raise the 4 in power. I've taught you that at the beginning of this topic, indices. You express 4 as 2 raised to power 2. So, choose one of the common bases across. So you choose 1. Where you have division, let the division sign change to subtraction at the power level. So you have 3 minus, what is the power here? Negative 1. The multiplication will change to addition at the power level, plus 2. The 2 we pick is not the 2 down, it's the 2 up, the power. So we have 2 raised to power 3 plus 1. Why plus 1? Minus times minus is plus, because two signs following each other closely without any figure or letter in between, the two signs will multiply each other. So minus times minus, as in negative times negative, is positive. So that's positive 1 plus 2. 2 raised to power 3 plus 1, that's 4. 4 plus 2, that's 6. That's 2 raised to power 6. 2 raised to power 6 is the same thing as 64. And that is the answer. Let's look at example 4. Simplify 12x raised to power negative 2 divided by 2x in brackets raised to power 2. We have 12x raised to power negative 2 divided by 2x times 2x. You know, that's the meaning of this. 2x in bracket raised to power 2 means 2x in 2 places. So which is 12x raised to power minus 2 divided by 4 times x raised to power 2. Do you understand? 2 times 2 is 4. X times x is xk. So we have 12x raised to power negative 2 divided by 4x raised to power 2. This is 4 times 3x raised to power negative 2 divided by 4 times x raised to power 2. 4 will take care of 4. So here we have 3x raised to power negative 2. This positive 2, you subtract it from the power of negative 2 as well. So we have 3x raised to power negative 4. This could be the answer, or 3 over x raised to power 4. Why? Listen, anytime you have 2x raised to power minus 1, it's the same thing as 2 over x. The x raised to power negative power will come down, and these two will come up. You have 3x raised to power negative 2. This could be expressed as 3 over x raised to power 2. The x raised to power negative value comes down, and it becomes positive when it comes down, and this 3 comes up. It's not by magic. This is what actually happens. Let me use another one. 5x raised to power negative 3. It means 5 times x raised to power negative 3, which is 5 over 1 times, this can be expressed as 1 over x raised to power 3. You know that. So 5 times 1, that is 5. 1 times x raised to power 3, that is x raised to power 3. And that is it. That is the principle behind this one becoming this becoming this, and any type like that. which is the same principle, making 3x raised to the power negative 4 to become 3 over x raised to the power positive 4. Let's consider example 5. Simplify 21x raised to the power 2 times 3x raised to the power negative 1. You can approach this in two ways. Number 1, 21x raised to the power 2 times 3x raised to the power negative 1. You can have it as 21 times 3 times x raised to the power 2 times x raised to the power negative 1. You understand? Separate the figures and the letters. So 21 times 3, that is 63 times x raised to the power 2 plus, because this is multiplication, it will change to addition. You now use the addition to add the powers together on only one chosen base. So minus 1. Minus 1, negative 1 is the power here. So we have 63 times x raised to the power 2 negative 1. How? Whenever you see two arithmetic signs following each other without any letter or figure interfering between them, then you multiply the two signs together. And don't forget, when you multiply negative and positive together, the result will be negative. When you multiply negative and positive, it's still the same thing. The result will be negative. When you multiply negative and negative together, the result will be positive. But when you multiply positive and positive together, the result will also be positive. In essence, anytime you multiply same sign together, like negative and negative, positive and positive, then your result will always be positive. Negative times negative, answer will be positive. Positive times positive, answer will be positive. But whenever you have positive and negative, whichever comes first, whenever you have positive and negative multiplying each other, the result will eventually be negative. And that is it. So here, you multiply positive and negative together, and the result will be negative. Can you see? So finally, you have 63 times x raised to power 1, because 2 minus 1 is 1. X raised to power 1 is x. 63 times x. So 63 times x is 63x. That is one approach. Another approach is, if you have 20, let me put all here, 21x squared times 3x raised to the power negative 1, expanding everything, 21 times x squared times 3 times x raised to the power negative 1. This is 21 times 3 times x raised to the power 2 times 1 over x. You know, this x raised to the power negative 1 is the same thing as 1 over x, which could be rewritten as 21 times 3 times x, x raised to the power 2 is x times x, divided by x. We have only one x at the denominator level. So that x will cancel this x. 21 times 3, that is 63 times x. Answer is 63x. It's the same thing, whichever way. Finally, let's consider this example 6. Simplify 7 raised to the power negative 2 times 21. 7 raised to the power negative 2 times 21 means this 7 raised to the power negative 2 is the same thing as 1 over 7 raised to the power 2 times 21 over 1, which is 1 over 49. 7 times 7 should be 49 times 21 over 1. Now, breaking 21 into factors, then 49 into factors, we have 1 over 7 times 7 times 21 is 7 times 3 over 1. 7 will take care of 7. So at the numerator part, we have 3. Because 3 times 1 is 3. At the denominator level, we have 7 and 1. So 7 times 1 is 7. That is the answer. Now we have come to the end of indices. And this is what I have for you as assignments. Please lay your hands on the assignment. Do justice to the assignment. And when we meet in the next class to consider another topic, we will start with the resolution of this assignment.